Okay, that was a mistake. I admit that. I was not supposed to stop the streaming. I was supposed to stop the recording. But sometimes when I get too excited, I stop the streaming instead of the recording, which admittedly does stop the recording as well sometimes. So it's, it does sort of accomplish the goal. But then everyone gets like a little offline thing, and then it's a complete disaster, and you know how it goes. So that was a mistake. I admit that. That's not a button that we wanted to push. And we will, try to avoid pushing it. But push it we did, and so now we're just going to have to live with that. So anyway, that mistake behind us, I'm going to minimize the window and say, welcome to Handmade Hero, the show where we code a complete game live on Twitch. No libraries, no engine, just our own sagacious ingenuity with the help of the Twitch chat stream to catch the mistakes that I will invariably make. We are going through absolutely every part of a video game, from the lowest little, tiniest little detail all the way up to the big picture, in an attempt to answer the age-old question, which is, how does a hero with no arms and legs fight their way through a magical forest? Right? It's a question that has plagued philosophers for generations. And honestly, I feel like it's time we laid that question to rest once and for all. And that is exactly what we're doing here on Handmade Hero. But before we can do that, we have to take care of a lot of technical requirements first that we have. And that's what we're in the middle of doing right now. What we're doing is we're creating a procedurally generated ground texture that will be unique everywhere in the game and that never repeats. And so we've done a bunch of the work that we need to do that, and we've discussed how we're going to do that, but we still have a few implementation things that we need to do today. And so we will probably do those today. However, depending on how much explanation I do, we may not get to the whole thing. So it may be a 2-day job. Well, we're not sure. We'll see. But I'd like to get started because we know what we're doing. We discussed it all yesterday and the day before, so it's not a mystery what needs to get implemented today, so we might as well just roll up the proverbial sleeves, even though my sleeves are rolled down. That's why I said they were proverbial and not literal in this case, and get to work. So if you have, if you want to follow along at home and you've ordered the game on handmadehero.org, you should have gotten a link with the source code download. You want to download the source code zip and unpack date 85 from inside that zip. That will put you exactly where I am today. So if you want to follow along at home, that is the thing to do. And if you don't do that, don't come back to me and say, Casey, I couldn't follow along. Because if you unzip the wrong day, anything goes at that point, right? You can't just go unzipping any day and then expect it to be the same as today, because today is today and no other day is ever today. Of course, if you're watching this stream on a YouTube video, that means today is not today. Today is some day in the past, but you know what I mean. And that's a very important thing. We're on the same wavelength. We've got to maintain on that same wavelength, all right? So stick with me here. Let's not go off on these ridiculous tangents that you seem to be encouraging me to do right now. Again, not necessarily directly, but in spirit. I know no one's actually talking right now, but I can sense it. I can tell that is what you were thinking, and I need you to stop thinking that entirely. All right, so let's go ahead and get back to what we were doing. So what we did yesterday is we had our tile scheme sort of working, but we need to actually start generating more tiles. And so we need a system that will go through and actually request the tiles that we need so that we don't just have this one sitting in the center. We need tiles that cover everything. So let's start by just doing that, and we'll work up from there. And so what I'm going to propose that we do is we start by making tiles that what I'd like to propose, this is a proposal, not in the awkward wedding proposal sense where the guy proposes to his girlfriend in the middle of a basketball game and she says no and he's really embarrassed and all these ridiculous things, which honestly are fantastic to watch on YouTube. I don't know if you've ever done it, but it's one of these really bad Schadenfreude things. If you go down that route, you will watch a bunch of them, but it's a lot of fun, so I recommend it. But that's not what I'm talking about. What I'm actually talking about here is I am talking about saying, let's take this one step at a time. So first, what we'll do is just produce tiles that cover things, and we'll try to make it so that as we move around, those tiles adapt to where we need them to be, right? That's something we obviously need to do. But they won't be seamless. So the tiles will just look totally wrong. They'll look like a tile map game where you have like these tiles that don't quite fit together right necessarily, and you see seams between them, right? So we'll do that first, and then once we have that working properly, we will go to, DEFCON 4 or 3, depending on what you want to call the previous DEFCON level that I just described. And that new level will be making the tiles so that they're seamless. Because they're two separate tasks, really. One is about determining what tiles to fill and making sure we evict tiles properly. And the other one is totally different. It's about filling tiles, the actual tile contents, in ways that naturally flow with each other. All right, so you got that? Good. I'm glad you do. All right, so let's start thinking. We've got some stuff. We have things to think about here, okay? We have stuff that needs thinking about, stuff that needs addressing. And the first thing that needs to be addressed is the fact that these ground buffers that we have, right? We need some way of saying what the ones we need are. We just have a big array of them and we can fill it up with stuff, but we need to know what the world positions are of the things that we should actually fill, right? And more specifically, we need to kind of place those things properly. And furthermore, the size of one of these ground buffers, we kind of want that to line up with world position. So we want to make sure that the world position that we give it lines up properly, with whatever, so that the pixels, the world units and the pixels line up properly for however big the ground buffer actually is, right? So let's think about this for a second, and exactly how we're going to do that, because there's definitely some issues involved there. All right, so in our ground buffer situation here, when we actually made our first one, we do this thing that's the test fill. This is the one that fills that one that we've got. So what we want to do is stop doing that test fill entirely. So I'm gonna take that out of there. And what we want to do is I'm just going to make a function here so I have some place to work in for this. I'm not exactly sure where I want to call it or anything like that. I just know what needs to happen. So I'm going to stick it in here and then we'll figure it out. What I need to do is I need to go through and essentially, I need to basically say, for every place the camera could see, I need a ground chunk there, and that will produce the list of ground chunks for me, right? This will produce the ground chunks that I actually want to have, right? That's basically what I want to do. But there's a little bit of an issue there with that, which is that our ground chunks obviously are stored in a way that makes it kind of tough for me to look up whether we have them or not, right? And so that's kind of an interesting piece of it as well, right? So we'll think about this in a second. But let's suppose that I was going to take that camera, right? So, and you know what, we kind of have some guidance here because in Handmade Sim region, we've got a thing that's like begin sim, right? We pass this bounds thing into this begin sim, which is like a region that we use for simulating the world in an area, and it's got like an apron around it and so on. And what I was thinking is, well, that's exactly the same sort of thing that we need to do here, right? That's exactly the same thing that we need to do here. And so if you think about preparing these ground chunks, we could think about them as being roughly the same as the sim region that we're talking about here. So like 17 times 3 times 9 times 3, right? That's how many actual tiles there are. But I think there's not that many in an actual, in a 256 by 256, there wouldn't be that many tiles. So I don't know, that's probably something where it's going to be reduced by a fairly considerable factor. So let me just see, what would so that was about 1, 2, 3, there's about 3 per screen. So if we did 3 by 3 screens and each one was a 3 by 3, it'd be something like 81 of them. So we could actually request something like the sim region in terms of how many things we actually need. We could actually do something like the sim region. Maybe that's a little too large, so maybe we want to shrink that a little bit, but we could actually request something of that size. But either way, you can see exactly what we're doing here is exactly the same thing that we want to do with the tile chunks. So we're just picking a region that's around the camera and we're saying, let's go ahead and fill in tile chunks in that region. So I'm going to assume that we can do that. And I'm going to say that we have basically request ground buffers, something like this. And I just want to be able to pass that. I want to be able to pass it something where, again, I've got sort of these bounds, if you will. So something like a bounds and a world position that's, you know, the center or whatever, like that. And I want to be able to kind of iterate through there and say how many chunks do I need to pull out for that, right? And I'm not really sure what the best way to do this is. I assume that the best way to do this would say, all right, from that center P, I would want to basically snap to whatever the closest thing is on that, which is really easy, you know, in abs tile X, abs tile Y, abs tile Z. That's actually pretty easy to do because that center P is already set up in that space, right? If I take a look at what happens in Handmade World here, I've got, in that world position, I've got the chunk X, chunk Y, chunk Z. So if I just ignore whatever the offset is, right, and say I'm just going to use that chunk X, chunk Y, chunk Z, that kind of gives me that basis. And I know that I could just go some number of chunks over, however many it would take to fill that bitmap, that 256 by 256 bitmap that we have. I know that I could just step by that until I hit the actual bounds. So I know this sounds a little confusing, but basically what I want to do is say, all right, I've got these bounds, the bounds that got passed in. I want to offset them by whatever the offset of the world position thing is, so that my world position will now be just a chunk X, chunk Y, chunk Z perfectly aligned. Does that make sense? So basically I'm saying, all right, I've got bounds here, excuse me, and I believe, I hope anyway, we already have code for this. It just adds to the min and the max. I don't know if we actually have that or not. We'll take a look and see. We have add radius to, rect min max. Do we have offset? We don't have offset. Wah, wah, wah. So we don't actually have that, but it's really trivial, right? If we have a rectangle with a min and max, we're just talking about adding something to it. And so much like we have add radius to, we can just do a thing where it's like, okay, if I have a rectangle 3, I can do an offset, right? And the offset just takes whatever the rectangle is, and it takes whatever the offset is, and it's just gonna, it's, you know, literally just going to do an operation to move the min and the max by whatever the offset was, right? So it's just that, very, very simple, right? And so I want to be able to do that. I want to be able to offset the bounds by whatever the center P was, right? And so the center P, when I take that in, that's going to have that offset, and I want to basically get rid of that. So what I want to do is say, all right, the boundary, and I'll just draw this out for you real quick. What day are we on here? Day 86, right? So here's day 86. So if you think about what's going on, right? I've got some bounds, and I've got, you know, basically a location for their center. And it's based off of some abs tile X, abs tile Y, abs tile Z, some you know, universal coordinate, right? That's an integer space. And it's got an offset. So what I want to do is I want to produce whatever this rectangle should be, but now around here instead of around here, right? So I want to essentially, I want to I want to subtract that so that I move the rectangle back as if it were around this thing. I don't know if that makes sense, but basically you can think of it like right now, right? I've got the min and the max, like, you know, the min is down here, the max like is up here, right? And so what I want to do is I want to take this vector for the maximum, and I want to be able to produce that as if I was here. And so in order to do that, I need to take whatever that offset is, and I need to include the offset in the max computation. So if previously the maximum would have been, you know, offset plus max, right? And previously it would have been offset plus min, right? This is where they actually would have been. What I need to do now is just roll that into the max and the min. So I'm just gonna pass that offset in directly, and that way it'll now be based around this this point instead, right? Hopefully that makes some sense. I don't know if it does or not, but hopefully it does. So I believe all I should have to do is just this code right here. so that I'm going to essentially have whatever the bounds were, they're now off of that. And then I can subtract that, since I've added it, I can subtract that away and basically say, okay, that the center P is now just an abs tile x, abs tile y. It has no offset anymore, right? Okay, so if I do that, then what I need to do is just say, all right, let me step in x and y, because we're not really considering z yet. And again, that's our next big task that we have to do. But let me take that abs tile x, abs tile y, abs tile z that we had there before. Oops. Where is my, there it is. I want to take these chunks, right, x, y, and z. I want to take those chunks. You know what? The only thing I failed to consider, though, is how big is a chunk is actually very large. So even though we'd be aligned here, we wouldn't really be, you know, a chunk is what, like 16 by 16 tiles? I wonder if that's just too large, because I could do it per chunk. I was thinking in terms of tiles, but these world positions are in terms of actual world chunks. We don't really have tiles anymore, right? They're just kind of a thing that's like was a thing for doing some world creation that's still sort of in there as a residual. But we don't really have those anymore. So if I'm producing one of these 16 by 16 tiles, that's a little dicey, isn't it? Because that may be too large for the granularity of our ground buffer, right? That might be too big. It's kind of hard to say for sure, right? But if you just think about it, that might be a bit much. Now, I don't actually know if that's true or not, but that's just what I'm thinking. Now, it would be nice if they aligned, because if they aligned, that would mean that we could just use, you know, we could have everything stored symmetrically. So this is a really, really tough call. This is a really, really tough call. So let's think about this for a second. If we were to, we don't really think about tiles per chunk much anymore, right? They're kind of not really super much of a thing. They're just a thing that we use to set that chunk dim. That's like the only thing we do, but the chunk dim could be whatever it is. And the chunk dim is in meters, obviously, and so, that's just how that falls out. And so if we were to say, for example, that one of these chunks was the size of one of our ground buffers, think about how much easier that would make things for us, right? It means we could essentially just sort of cache these ground buffers directly with the world in a more direct sense, right? We could do something that was really, really easy. We could even maybe store them in here. We could store, it seems a little wasteful, but you could imagine having the world chunk say in here, like have an index into the ground buffers array that says what ground buffer it currently has, if it has one, right? So man, it's really tempting to go that route, and I'm kind of thinking that would be nice. The only thing I don't love is, storing it in here seems a little bit unnecessary. That seems possibly a little bit excessive, but, who knows? It's hard to say. I think I'm going to try that. I think I might try that. Let's see what would happen if I were to do that. Let's take a brief interlude from this, right? And see how big those tile chunks actually are. So what would happen if I were to draw the tile chunks, basically, right? So let's do that. If we go in here to where we actually draw stuff, right? If I were to actually draw the tile chunks that are involved in the sim region, like what would that look like, right? Because if you remember inside sim region, I'm sorry, not sim region, that were visible on the screen. If you remember, we've got this code right here that basically does exactly that. It iterates over the chunks that are involved in a particular bounded region, right? And so if I were to do that, I could, make a thing here that just does that rendering, right? So let's just do that. Let's see what that does. So when we make that sim region right here, and it does that begin sim, right? I'm actually going to do a thing where I, right in here, I do a little rendering where we render the chunks that are in whatever the sim region, a sim region sized sort of thing is. And it won't actually be the sim region, it'll be just more some kind of a screen sized thing, right? So if I did it this way, right, like this, I'm going to go ahead and make a little piece of code for us to do this here. So if I do this camera bounce thing and I say, all right, how big is the actual camera's region going to be? I can do that pretty simply by saying, you know, I've got meters to pixels, right? And so if I have meters to pixels, I can easily get from pixels to meters. So if I want to know how big the camera's bounds are, right, I know that the width or the screen width in meters, right, is going to be whatever the screen width was in pixels, right, which is this, divided by that meters to pixels, right? Which is, I don't know if we store meters to pixels. I don't know if we store pixels to meters. We probably should. Pixels to meters, right? So I'll just multiply it by pixels to meters, which is just the inverse of meters to pixels, right? So we've got meters to pixels. So let's go ahead and say pixels to meters. I guess I don't need to store it in the game state. Oops. I can just do it here. 1.0f over meters to pixels, like so. So let's go ahead and just do it that way. So the screen width in meters is just going to be whatever it is in pixels times pixels to meters, right? That converts for us. And similarly, whatever the screen height is in meters, I'm going to do that as well. Once I know that, I can trivially make a rect center half dim out of that and just pass that in, right? It's just going to be a v3 of screen width in meters, screen height in meters, and we don't really care how thick it is at the moment because we're not really handling Z for ground generation quite yet. So once I do that, I can get those chunks out there, and the origin in this case is just going to be that camera P. It's going to be wherever the camera actually is, right? And then I can get it the camera bounds again, like so. This will basically give me the region that we're viewing. And then what I can do inside here is when we go through to draw these chunks, chunk Z, chunk Y, chunk X, we're looping over all the chunks. When I grab a world chunk out, I can go ahead and say if there was a chunk in that location, I'm going to draw a rectangle that sort of encapsulates the region where that was, right? And in order to do that, again, I just do the reverse mapping, pretty straightforward, right? All I need to do is figure out how big a chunk is by half, draw that at the location where the world chunk is in terms of, you know, its exact placement, if that makes sense. And so if I take a look here at what one of those chunks gives me, I have the chunk X, chunk Y, and chunk Z, right? So it's pretty free for me to create a world position that has that and ask for the difference between that and the camera, just like we've been doing a million times before, right? So I have a world position. This is the chunk center, right? And that's just going to be equal to, excuse me, the chunk center's chunk X equals whatever the chunk X is. And you know what I probably should do? Do I already have a function for getting the chunk center? Because that's what I would really like. Centered chunk point, that's what I want. So what I really want to do is have one of these that just gets me it for a chunk, and that's pretty trivial to do as well. So centered chunk point that just takes a child chunk world chunk like that, and actually does this for it. That's exactly what I want. So I'm going to grab one of those, and I'm going to say that that's just equal to whatever this chunk had in it. And so that's going to get me the location. Oops. That's going to get me the location of that. Return result. There we go. So I'm going to do that. And so I can just say centered chunk point, right? And that's going to be the centered chunk point of this chunk. So then I could do my subtraction and find out where it actually is relative to the camera. So this is the relative center P, right? And all I have to do there is say, I want to know how to get from the camera, right, to that chunk center. That gives me the relative P, so then I'm good. And I can now draw the rectangle to whatever the draw buffer actually is. Now, I think, We just need the rel p xy here, and this again has to be in meters to pixels, right, as we always know, and it also has to be plus the screen center x, plus the screen center. Do we have, where is our screen center? Do we actually compute that as a, we never actually, we need to make this an actual x, this actually needs, it's been too long coming. This actually needs to be just a vector, right, that has the things in it that we need. Something like this, right? There we go. There we go. And again, so this is again just kind of compensating for our lack of renderness. Screen center plus meters to pixels on that relative one. And yeah, that should basically draw it. We just need to know how big it is now. And to know how big it is, all we would really need to do, I've got to give it a color too, I suppose. Let's make it a lovely yellow for now. In order to draw that, we would need to know how big it is. How big a chunk is, I'm not sure. Do we have something that gets chunk sizes out, or do we have to access directly? I mean, it's in there, right? It's chunk dim in meters, right? So it'd just be half of that. I guess what I could do is just say half of whatever the world is, chunk dim in meters, right? Dim in meters dot xy. That's the half of that. And so that would draw it. So I can do that. I got to fix the stuff that I did. Where is draw buffer defined here? There we go. Let's go ahead and move that up. So probably should move this render comment up too. And this is all for the draw buffer. Like so. Like so. Pixels to meters is not off the game state. It's just a variable. And subtract needs to take addresses of these guys. And of course it needs to take the world as well. Screen center X, screen center Y, that I just made into a vector. And this is actually, I could have just done, if the bitmap width was actually v2 here, this would be a nice vector equation. Probably should clean that up at some point. One more time. Let's do that. All right. So let's take a look at what that does. I wanted to see if that would do some, and it does absolutely nothing. Oh wait, but you know what? That's because I put that, you can't clear the screen after drawing stuff. Yeah, to say the least. This right here clears the screen, so that kind of needs to be happening at the very outset of rendering, to say the least. All right, let's try that one more time. So do I actually see any boundaries? I do not see any boundaries. Why do I not see any boundaries? Let's double check what's going on in there. Let's take a look. Okay, so we come in here and we clear the screen, which is good. We grab that screen center, and so then we come in here and we grab the screen width in meters. It's 22 by 12. We never knew that before. This is the first time we know how big our playfield is, 22 meters by 12 meters. Then we're going to make that camera bounds. Let's take a look at what that looks like. Camera bounds, negative 22, 12, 22, 12. That's wrong. I should have said I don't know why I said half dim. That was a mistake. Has nothing to do with our problem, but that was not true. That's supposed to be rectangle center dim, because these are actually the size of the whole thing. So yeah, slight mistake there. You know, it happens. Let's go back through. And so then when we map these into chunk space, let's take a look at what happens there. Min chunk P, max chunk P. And so we're going between chunks 0 and 1. That seems fairly reasonable. And there should be chunks there because we have some world stuff there. Let's take a look at what the chunk center P returns for that, and that is what we would have expected. Let's see what the relative P comes back as for that. Relative P. If we're going off the camera. Again, totally reasonable meters for that as a particular point. And so I wonder what, oh, again, yeah, we need to, I can't wait till we get to the render so we don't have to keep dealing with all of this. Obviously, this is in meters, which is no good. we need this to actually be in pixels, right? And that's really just something you want to set all that up on your render and then forget about it. Oh, right. Well, two things about this. One is I have to remember to actually draw a rectangle. I need to remember to actually draw the rectangle as a border, but also I'm doing something weird there where it seems to be snapping to the camera's location. And I'm not sure why that is. So let's see, screen centers plus whatever the relative position of the thing is relative to the camera. That seems right to me. And then the dimension, not sure why that was doing what that was doing. That seems kind of odd to me. But that's okay. We'll debug that in a second. What I want to do is draw a rectangle outline, which I believe we actually did here, right? Didn't we do some kind of an outline? Outline, push rect outline. Ah, of course we didn't actually. Looks like we never actually gave ourselves one of these that draws it directly. Well, I suppose I'll just make one. Let's see. Draw a rectangle and draw rectangle outline. So let's do draw rectangle outline. And we'll have that take exactly the same stuff as our draw rectangle function did. And this will basically do exactly the same things that we were doing before, except it'll do things in pixels instead of doing them in meters like it was doing before. So we'll do a thickness here. We'll say that it's going to be, I don't know, 2 pixels thick, I guess. That seems fair. And so then we'll just call draw rectangle with each of the pieces, just the same way that we did them before. So there's that buffer, right? And then we just need to look at, none of this stuff matters. We don't have offsets these. We just have mins and maxes. So let's get rid of that, and get rid of that, and get rid of that. And the RGBs will be the same. RGB. RGB. Oops. Of course, this is a little bit nasty what I'm doing here, because usually when you're debugging something, you don't want to introduce a new function. So yeah, we'll probably have to test this and make sure that it works properly before we actually use it for anything. But that said, when we do this, let's see, we should be able to do this by inspection relatively easily. We have a min and a max, and then we just need to know what the thickness stuff is. So if we're producing new mins and maxes from this, it's going to be pretty straightforward, right? Basically, all we need to do here is say, for the top and the bottom, in fact, I don't even know why I bothered copying and pasting this code. This is so simple. But for the top and the bottom, to produce the new minimum, right, we just want the actual minimum. In fact, I can do this in terms of, I'm just going to do this way, right? Fill it in exactly. Okay, so same exact drill as before. If I want to draw this rectangle, I'm going to start, in the bottom left corner, and obviously I want to start on the left and draw to the right. So the min and the max are exactly the same for the x coordinate here, right? If that makes sense. So they're just going to draw from and the same would be true for this one, because we're just drawing the same rectangle from left to right here. Nothing particularly odd happening there. There is one thing we might want to do where we probably want to back up by the thickness. So we could say that this is minus, let's just call that t, right? So we'll back up by the t, and then we'll go out, on the t, right? And you know what? I'm not even going to call this r for radius, because really we're going in and out by it, if that makes sense, right? So we're going to do that, and then our our y minimum is going to be just the min y minus the r to the min y plus the r, right? Or the v max y minus the r and the v max y plus the r. So again, I'm just drawing from the left to the right, and then using either the minimum, a little bit around the minimum, or a little bit around the maximum to produce that thick line for my rectangle outline there. And then the exact same thing in swizzled around for the left and right sides, right? I'm going to say, okay, I want to draw from the top to the bottom, right? So in this case, it's my x that's going to go. It's my x that's going to go just within a narrow band of itself, like so. And it's going to be the left side is going to be the min. This side is going to be the max. The right side. Not having a good typing day. There we go. And same thing here. Right. Okay. And the y will range between its full range from the min to the max, as you might expect, and that'll happen the same in both cases, right? So nothing particularly odd there. Okay, so let's just spot check this again for top and the bottom. So first we're going to draw the top, and really this is not actually true in all cases. So we probably should say min and max x, because if we flipped our coordinate system, it wouldn't be top and bottom. In that order, it would be bottom and top. But either way. So we start off with that min, and we subtract r from it because we're trying to be a little bit further to the left when we start. And we go to the right. Again, start on the left, go to the right. And for the top and the bottom ones, we do first the min, minus r, and plus r. So we're just doing a radius of r around that min. And then the same with the max, right? Very straightforward there. Then doing it the other time, we're doing exactly the opposite. So we're going to start at the top, start at the top, go to the bottom, right? And then for that top one, we want the left side minus r, the left side plus r, the right side minus r, and the right side plus r. So that seems pretty reasonable. And we could also pass this in. So if we wanted to, we could just make the thickness a parameter, so we can draw the things as thick as we want them to be, which seems pretty reasonable. Oh, oops, forgot we have an r. So I can't do radius. Oh, all right, back to t. Back to t it is. So sad. What we really need is for that just to be color. In fact, you know what? I'm going for it. I'm going for it, people. Are you seeing this happen? It happened. Right there. You saw it. You saw it, didn't you? I know you guys saw it. So there we go. Lovely. Okay. Oops, and that's R. Now, this is going to be draw a rectangle outline now. And it does not take 6 arguments. That's true because, oh snap, I just added a color vector. And so now it is. All right. So now we just have to figure out what I totally computed this wrong. And I don't know why. And so we're going to have to go figure out what on earth is happening there, because that's just totally wrong. You can see it's almost right. Right? It's almost getting to the part where it seems reasonable, but it's still kind of just kind of messed up. So let's try and figure out what's going on there, because I have no idea. And if I don't have any idea, then we can't move forward. Okay, so drawing a rectangle outline, that looks like it was doing exactly the same thing as the filled rectangle was doing. But so I don't know, there might be some bugs in it still, but at the moment I want to go back here and just take a quick look at this and see what I was doing oddly. So when I was finding, I guess let's see. We did the rect center dim, map into chunk space. We mapped into the chunk space, so now we've got chunks. We're iterating over the chunks. We get the chunk centers out. We subtract them from wherever the camera is, which gives them something relative to the screen center, which is what we'd expect, right? So this should be drawing a rectangle. I don't really understand why that is failing to draw the rectangle that we would expect. Screen center X plus meters to pixels, rel p xy, because that is whatever the distance is between that chunk center that we just got and the camera p. So what's the problem? Meters to pixels, we are scaling properly, and we're offsetting properly. I'm confused. I do sort of wonder, if there's something weird going on here, but I suspect there probably isn't. Oh, duh. Draw a rectangle does not take a width and a height. I just, instead of looking at it, I just was like, oh yeah, the width and the height, it's taking width and a height there. Because I looked at that function, but that just happens to be based off of 0. So that's just stupid. That was just me being dumb. I don't know if that's Owl of Shame worthy, but it's just me being stupid. So really, if this is draw rectangle outline, what we need to do is say there's the screen P of it, right, is this. And then we need the screen dimension is this. And we need to actually compute the min and the max, right? So it's minus screen dim, like so, screen P plus screen dim. Simple. All right, so that was just a bunch of stupidity. Oh, and of course, again, we have our Y flipping problem. That is always super annoying. I feel like that's one of those things where you're just like, at this point, I probably should have just introduced some render stuff at the beginning because I've said it so many times, but it's always really hard to know, right? I mean, you never really know what's going to save you time versus cost you time. Sometimes it's really clear, and other times it's just not. And like maybe it's still the case that this was a smarter thing to do to just handle it all the time. You know, it's just really tough. And so I don't know what the answer is to that. I really don't. All right, so we're getting there, although we still have a problem, which is our chunks are drawn too tiny, right? Because obviously that can't be what the chunks actually are, because if that was how big the chunks actually were, then they would not actually be able to cover everything. So I'm off by a half there. Let's see why that actually is the case. So, oh, because I already did the half dim here. That's why. All right. All right, so now we've got our chunks and we can see how big they are. You can kind of see that they're like way too large, I think, for storing. If we were to use those as our ground buffer points, I think they're much too big. And so I do wonder a little bit if maybe we should make them smaller and try to go with that as our tiling size so that everything's kind of uniform. So I don't know if that's a good or a bad idea. Let's take a look at what would happen real quick. If I was to change that size down so that it was a quarter of its size, right? I don't know what would happen there exactly, but you can kind of take a look at this and see. That's a more manageable size of a chunk in terms of something that we would use, right, to store graphics. I feel like that's not, it's possibly a little larger than maybe I would want, but it's workable, right? It's a workable size. And we could even go potentially a little bit smaller than that. It depends, there's obviously costs involved in doing each of these things. But you can kind of see now where we're at. And so maybe we just try doing the ground chunks at that resolution, and we see how that goes. So the other thing we could do now is actually set that chunk size based on what we want, how big a 256 by 256 block is actually. So for example, we could say, instead of this having anything to do with tiles per chunk at all, in fact, because we don't really care about that anymore, right? Tiles per chunk is literally not a thing. If you take a look, it just doesn't matter. So what we could do is instead figure out how big 256 by 256 is and just say that that's the size of the thing that we want to put there, right? And make sure that chunks are exactly that size in float space so that it all kind of just works out relatively nicely. This would also be a good, if we were being super conscientious, we would probably also want to make our meters to pixels something integral, right? Because right now our meters to pixels, we're setting that as some kind of particularly odd value. And so if we were going to set it, let's see what it actually is. Maybe we can set it to something that's going to be a little more amenable to making the renderer and the world kind of get along nicer in that sense, right? Let's take a look there. So when we set our meters to pixels, right here, what's it coming out to be? Game state meters to pixels. So, that's not a particularly friendly number. Similarly, the inverse of this, not a particularly friendly number. So it would be kind of nice if there was a way for us to make these things be relatively well behaved, right? Like a power of 2. So if we were to change it to, say, 32, it's in between 32 and 64, right? But like, if we were to do that, I wonder how hard that would be for us to get by if we were just say meters to pixels, is going to be 32. That's just what it's going to be, right? That obviously changes the scale of our world, right? But it's kind of arbitrary where we place those things. But that looks kind of nice as a tiling size, and we can just make our tile side in meters. Our tile side in meters our tile side in pixels, we could change. We could make that kind of fungible to make it a little bit larger, right, or something like this. Because then we don't really care. Tile side in pixels is just something that we're using as a purely synthetic concept. In fact, let me get rid of this. We can just get rid of this for now. So let's say we were going to do that, right? When we were actually doing that in our world, let's see here. When we were doing this in our world, we initialized things. Where was it? Right here. Tile side in meters. So where do we actually pass that in? Where do we set that? First of all. So I don't actually know. Initialize world, we set it right here. So we pass the tile side in meters, and we put the tile depth in meters, right? And like I said, I don't know that we really care about that particularly much. That tile side in meters is really just something that we're using as a totally synthetic concept. So I'm thinking that we could probably do without it, right? Because really what we're doing is we're just using it for this world creation stuff, the chunk position from tile position. That's really the only place we're using it at all. So I think we could get away with this. I think we could. And if we did, I think there'd be some bonuses for us in that. So I think maybe that's something we want to. I think that's maybe something we want to try. So if we were to initialize the world, let's say not with that tile side in meters, let's just see what would happen if I start to pull that concept out. So tile side in meters is no longer going to be in there. I guess tile depth in meters. Let's see what happens if neither of those are in there. Who's all the people that need it, right? So the people that need it are other than our initialization. There's this function which tries to do things in tile space, which we use only for world building at this point. There's that's the same thing. That's all the same thing. All right, so here, this is basically just to do how big we want things to be for collision detection purposes, which again we could just is purely arbitrary values that we just size to our own taste. Same thing with this. This is just camera bounds picked randomly. In fact, this could now be driven off the screen size, which would be even better. So it looks like really there's just not that much to this. So let's try it. Let's try going without it, right? And instead making that chunk dim in meters be something that's derived off of a screen size, off of something that'll be easy for us to work with in a more exact way, right? So when we do this initialization, what I want to do is I want to just pass the chunk dim in meters directly in here, like so. So we're going to pass that chunk dim in meters, and we'll just assign it, right? Chunk dim in meters, like so. That's all we need to do there. We're going to go ahead and move this guy, this function out, because now this is going to be something that's really only used just temporarily with our world building stuff, and we'll get rid of it entirely once we move to a more free-form world building. So right here, we don't even need to know this stuff. So we just have to have whatever that tile side in meters, whatever we want it to be. We can say that it is what it is for now. Tile to meters is 3.0, just to use the old values. But again, because this is totally throwaway and not important at all. So that'll be in there, which is fine. Let's see. Chunk position from tile position. Got to put that up a bit higher. Okay. And then we just need to fix these values, because this is something that people were using for, figuring out how high things were. And so these are sort of game spec-y kind of things. So maybe I'll take this opportunity. This is turning into much more of a cleanup day than I expected. I was going to work on the ground stuff, but I always like to take the opportunity to do things more right when I can, because you always try to move things toward a good state, and that's just, something that we kind of need to do. So I don't know, this kind of feels like we want sort of a set of game metric things in here, and I guess I can stick them off of the game state for now. That seems totally fine. But this will basically be something like, our floor height kind of a thing, like typical floor height, and that'll actually be, what these people would use for tile depth in meters, if that makes sense. And that'll be set to that 3.0 value. Let's see here. Tile depth in meters. This will be typical floor height. Let's keep going here to other people's stuff. Initialize world. So that's going to be that chunk dim, right, in meters. And sort of what I was saying there was, okay, so if meters to pixels is 32, then a chunk dim in meters, I kind of want that to be based off of this value. So if I initialize some of these here, if meters to pixels was 32 and the ground buffer height, right, so ground buffer width and height, these guys, if I move them up here and think about these a little bit, if I just leave those up there for now, if I want these guys to play nicely with this, right, just trying to think of how I could work out these values. So 256 divided by 32 is 8, right? So that'll divide perfectly if I want to say the chunk dim is the same number of meters as a ground buffer, right? So all I would have to do there is say, all right, and you know what, I'm going to go ahead and do my meters since I'm using it here. I'm going to say pixels to meters. So if I want to make this come out exactly, which I kind of do, right, just because I want to make it so that we're not having to do a bunch of fractional things when we're actually talking about pixel stuff. So if I have both of these, and then I want to know how big that chunk dimension should be, right? So this is the world chunk dim in meters. Really all I have to do is derive that from these two values. So if I make this, this here, what I would do is I'd take the pixels to meters value and just take whatever that ground buffer width is that I want, and say, okay, that's going to be how big the chunks are, right? So now we just know they're 256 by 256, right? And similarly, I can do the ground buffer height here, buffer height, same way. And then the world chunk, we were just kind of saying that they were, I think we were saying they were 3 high, but I don't know what we're going to do with that eventually. Again, that's more Z handling stuff we've got to sort of work out over time. But once we've got that, what's that typical floor height? This guy right here, right? We'll do game state, typical floor height, and that'll be just set to there. Yeah. Okay, so that's fine. Tile side in meters. again, this is kind of just like how big those stairwells are. So tile side in meters, I don't really know what we want to do there. I mean, we can sort of leave that in here. We could do that for just for these guys. Tile side in meters. We could just say that it's still what it was before, even though there's no such thing as a tile anymore. But that's fine. And similarly, the tile depth in meters was the typical floor height. And then we just get rid of all of these. So we kind of are just using those in the world builder now, which is really where they should have only probably existed in the past, because the other stuff doesn't care about this at all, right? Tile side in meters. Yeah. Tile depth in meters. Tile side in meters. And so this is the camera bound stuff. So I think the camera bound stuff actually should be done a little differently, right? Because now we're actually producing proper camera bounds, because I went ahead and did that, right? This is actually the camera bounds. Screen width in meters, screen height in meters, right? It's camera bound in meters anyway, I should say. And so if we do that, I feel like the best thing to do would be to use that for our sim region as well, right? Because instead of this nonsense with tile spans, which we don't care about, they don't have anything to do with anything, what we really want to do is say, look, the camera bounds for the sim region, right? So we could call this sim bounds or something, right? The sim bounds should just be the same as the camera bounds with an apron added, with some amount of apron added, right? So really all I want to do is like add radius 2, whatever the camera bound in meters is, and then just say however much sim space we want to add beyond that, right? And so that's, I don't know what amount that actually is going to be, but if we were to say, okay, we want to go, I don't know, 15 meters in each direction or something like this, right? Then that's how much we would do. I could actually say sim bounds expansion is this, right? Like so. To do how big do we actually want to expand here? And there we go. So yeah, so that's a bunch of randomness that I just did. And let's find out how badly I broke everything. So it seems like we're still in exactly the same situation that we were in before. So that's good. And yeah, it looks like we might, the only thing about it is that does seem kind of tight in terms of our zoom level there, like our meters to pixels in this case, being off. So I guess we maybe want to let it be a little bit different than that. We might want to say, all right, let's do something where it's a little closer to what it was previously, something like 48, right? Meters pixels. That was very close to what it used to be, right? So this is more our speed, right? That puts a little bit closer, or I could do it as exactly 42. I wonder what that actually ends up being. 1.0 OF over 42, 0.238. It's still, it would be really nice if it was a power 2, but I don't know how sensible that actually is. And since the renderer scales things, I don't know. But we'll go with this for now. All right. So at that point, we're almost out of time, unfortunately. I spent too much time. Well, I kind of spent the time that I think we needed to spend going through that stuff and working it out properly. But what I need to do now, right, is once I have that going, we're in a position to actually do the stuff that I wanted to do at the outset, which is when we're doing these rectangle outlines, we are now in the position to request a particular world chunk, right? So if I wanted to draw a world chunk here, what I could do is I could say, all right, when we draw those world chunks, because we were drawing them before, right? So ground buffer, we're drawing these ground buffers here, right? When we're drawing these ground buffers, what I could do is say, all right, I'm going to make sure that we have whatever the ground buffer is that we would have needed here, right? I don't know if that makes sense. And the ground buffer that we would have needed here is whatever this chunk center P says we needed, right? So we would look through and we'd say, oh, okay, for that chunk center P, and this is not the code we actually want to use, but we'd say, okay, ground buffer index, right, equals 0. Ground buffer index is less than the transstate ground buffer count, right? Plus plus ground buffer index. And we basically say if, we could find this one, right? If we could find one, the one that we actually want, then we would not have to do anything. But if we can't find it, then we have to actually produce one, right? So we'd be doing a loop there where we basically be saying, all right, for each of the ground buffers, if the ground buffer in question equals the one that we want, then we can forget about it, and we found it, right? So found false, right? Found true. So if a particular ground buffer that we're looking at, ground buffer index, if that one's location is the location that we actually want, right? So if its P is equal to, excuse me, is equal to whatever that chunk center P is, right? And we have a comparison function for these, I believe. Let's take a look here. Is canonical, are in same chunk, that would do it, right? So we could say are in same chunk for these two. If that's the case, right? If these two things were in the same chunk, then that means we already have a ground buffer for that. Else I'll say, if this one is not valid, if this particular ground buffer is not valid, I should probably actually get the ground buffer out here, huh? Ground buffer. Ground buffer. So I grab the ground buffer out. I'll say, okay, if this ground buffer's position is the one that we want, then we know we have that ground buffer already. And if, on the other hand, its position is not valid, so there was nothing in this ground buffer, then that's actually a ground buffer we could use to fill with the one that we actually wanted, right? So we could say, oh, okay, excuse me, we want to actually fill this ground buffer, so I'm going to store empty buffer here and say if it wasn't valid, we'll just grab it. Now, like I said, this won't actually ever evict anything, so this is not the code we actually want to use, and it's also extremely inefficient. There's that. But for now, this will actually just sort of do a little bit of it. So at the end of this, if we haven't found it and we found an empty buffer, then we just want to make, we want to fill that buffer. And we've got that fill ground chunk that we already did, so we can just call that with all the stuff that we needed, right? Pass that empty buffer, and we know which position we're trying to fill. It's the chunk center P, right? And that will fill the chunk. Excuse me. Right? Really pretty straightforward. Nothing particularly odd going on there. Function does not take 2 parameters. Really? How many does it take? Oh, because we have an assertion in there. All right, well, I can pass you the world. I'm fine with that. And this needs to be an address. So let's take a look at what that does. So for some reason, well, we're almost correct. But for some reason, we're not quite enumerating all of the chunks. But you can see we're almost there. We just don't quite have it. Now, we'll run out of chunks eventually. But you can see we're almost there in terms of what we need to do for the basics. But for some reason, we're missing one chunk. And it's like when we iterate, if we're on it directly, it works, but otherwise it doesn't. That's kind of a bizarre bug, wouldn't you say? Pretty unusual. And then eventually here we should run out of these. In fact, I'm kind of surprised we haven't run out of them already. I guess we made a lot more of them. But you can kind of see how it's working here. All we'll need eventually is an eviction scheme, which we should be able to do tomorrow, and then we'll be in good shape. But we have a bug here, and I don't know, we could probably leave that bug till tomorrow. I'm not too terribly concerned about it. But boy, you can go for a long time. This is kind of weird. How many did we say we had? There we go. Finally, I've got to the end. I'm like, we're not evicting anything, so we should be able to get to the end. But it took a long time. I guess that's when you have a pretty big cache there. It's all good. All right, so what I was saying, though, is I'd like to take a look and find out. It's a little bit weird. I'm not sure why we're getting that that bug where we're not ever producing one of those chunks there. That's a little bit odd, and I'm not sure why that is. We're doing our loops properly from Y, from the min chunk to the max chunk, and we're actually including that max chunk as well. We're doing that on X and Y, and so it would seem like that should work, but it's not. And so something that we've done here is off. It's not actually filling the chunks that we think they're filling, or I guess there could be a problem with the way we're rendering them, but that seems a little less likely. So I'm assuming that it's something to do with the way that we're actually filling them in here. And I'm going to put to do here also, to do. This is super inefficient. Fix it tomorrow. Also, it doesn't evict anything. So I'm just going to take a little bit. How much time we got? I'm only 6 minutes over. I'm just going to take a little bit of look here to see if I can just spot what I did wrong, because I would like, you know me, I don't like to leave bugs like that. So I'm just going to take a quick look to make sure I can't just see what it was that that was done stupidly here, right? All right. So if we have the camera bound in meters, we know that that's the whole screen's worth. We're then going and mapping that into chunk space to get, you know, the min and the max there, the two corners of it, which seems like it should be pretty straightforward. We're looping through those, getting to see if there's chunks that, oh, right. It's just, haha, this was working totally perfectly. It's just, I was only drawing, since this was a drawing loop before, I only drew it if there was a chunk, if there was actually data in the chunk. Whoops. So that's it. Yeah. That's all there was to it. So that was kind of funny. So what was happening is there were no entities in those chunks, so it just skipped them. But then when I would move into it, my entity was in the chunk, so then it became active. That's kind of cute. You gotta admit that's kind of cute. But problem solved, and so there you go. And so now really all we need to do tomorrow, we have some issues we probably will have to address when we want to get things totally right, like how these things line up exactly, whether they abut properly, and how it scales up and down. There's some stuff we're going to have to address. It's not all unicorns and rainbows at this point, but all we really need to do tomorrow now is generate them seamlessly, which is not really that hard. And then we'll be good to go. Now, of course, like I said, we still want to put this on a separate thread and make it more efficient and stuff like that so that we don't get hiccups like we're getting right now. But on the whole, this scheme's working quite nicely already, and we haven't really even done anything fancy with it. So I think that's pretty cool. Or at least I think it's pretty cool, and hopefully you think it's pretty cool as well. So yeah, with that, I think we can go ahead and go to the Q&A. Please prefix your questions with Q colon so I can see them. Yeah, and I'll answer them. So you can see here where we still had some alpha that wasn't quite all the way in, right? And so you get some of that showing through there, I guess. I'm not exactly sure if that's what that's from or not. It's an interesting artifact. It's the chunk boundary. What is muratory syntax? I'm not sure what you're referring to, but you could be referring to muratory for syntax, which is this. Right? I don't know if you can see that. But basically what that is it double brackets everything. And the reason for that was because in the old days, there was no possible way you could have a compiler. There's no way you could write code without doing it this way that would ensure that the compilers would always do the right thing with respect to scoping for. Because MSVC would put it in the outer scope and GCC would put it in the inner scope. So this was a way of putting an extra scope in there so that MSVC would behave the same way as GCC. It's not necessary anymore, but in the old days, it was the only way to do it. Will the random ground splats be based on some seed so that the ground buffer can be regenerated the same as it was after it gets evicted? Well, not only will it be, it is. See? It's already based on whatever chunk it came from. And so that's kind of cool in that it will always be able to regenerate itself. And that's going to be pretty handy too, being based off that, because we'll use that to make it seamless tomorrow as well, which will be nice. I'm sure it's been asked a bunch, but any tips for what language to start with and how to start? Not really. It's been so long since I started, I don't know. So I've said many times on the stream, really the answer is whatever gets you into programming. Whatever you can find that seems like you're having fun with it, if you've literally never programmed before. Because what we're doing here with C is too hard for someone who's never programmed before. It's, right, like C and C++ are kind of the advanced language, right? They're definitely when you have your adult pants on, and your little baby pants should probably not be the same pants, right? And so when I was little and I started programming in BASIC, and and then I went, I think, to Pascal after that, but that was the same as C more or less. And then I went to C after Pascal kind of faded out of popularity. And so I would recommend probably a similar two-stage process. I'd recommend some language that's easy to use and forgiving and has a good standard library and isn't for writing efficient code or doing a lot of the stuff that we do on the stream, but that lets you play around with it and be happy with coding. And then once you're ready to level up and start taking more control over things, then you can come, to C. Ha! Someone said they actually found a Muratori for statement in the wild. No way. That's crazy. I had no idea. I didn't know anyone used it but me. So that's pretty interesting. I wonder what that is. Yeah, you're right. There it is. Ray find obstacle. Very interesting. That's very, very interesting. And it's only in that one routine. I direction, hit distance, hit index, hit location, hit normal. It doesn't really look like my code otherwise. So I don't know. That's kind of weird. I wonder if someone yeah, I don't know. That's very interesting. I wonder who wrote that code or why. That's bizarre. Thanks for the reference. Why are you not passing world as an address when calling functions? I'm pretty sure we are. Where are you seeing us not do that? Like, here's a world pointer, and I'm pretty sure pretty much everyone, it gets passed as a pointer, right? It's almost always passed as a pointer. Where do you see it not being passed as a pointer? Would be my question. Are you going to implement Z buffers and texture scaling? Z buffers, no, because we don't need them, and so they'd would be both inefficient and lower quality. So we will just be doing sorting, because then we can do proper alpha compositing and not have to do any Z buffer stuff. But I don't know. I mean, I suppose we could use an early out kind of Z buffer. We're not going to have, yeah, I don't think so. If we did anything that was like a Z buffer, it'd be more like an occupation buffer, like an occupancy buffer that was just designed to early out chunks of the screen. Texture scaling, though, yeah, we'll be doing, and rotation. Any other questions? Does not look like it. Is there any other possibility for a Z buffer? I'm not sure what that means. What do you mean by is there any other possibility for a Z buffer? Z buffers for 2D games, it's unclear why you would ever use one. I mean, one reason is if you were doing very expensive shader calculations, right? And you were trying to use the Z buffer, you were trying to draw front to back and use the Z buffer to early out so that you wouldn't do shader computations or something like this, right? Instead of drawing back to front, you draw front to back with destination alpha and save those shader calculations, right? And you know, we could do that. But you still don't really need a Z buffer, even in that case, right? You don't need a Z buffer, you just need a binary buffer at that point, right? Like something that says yes or no. And you still end up with the problem that it's like, yeah, I mean, you can't actually early out on the alpha edges, so I don't know. It sounds dicey to me. But I'm not a rendering expert, you know. I'm not one of those guys who spends all their time thinking about rendering. And so maybe there's a good reason why you would do it. But I'm imagining that for us, you know, some kind of a coarse occupancy thing, and then just render, you know, front to back with destination alpha, or and if alpha's 1, then you early out, would be the smartest thing to do. Because I can't see the Z buffer ever really coming in. And especially if you do front to back with, especially if you did front to back with destination alpha, I feel like wouldn't you then just use alpha to determine whether you kill or not? Yeah, I'm sorry. You'd have to ask somebody who was more of a hardcore rendering guy whether there'd be any reason to use Z buffer. It seems like the only thing you would ever do is use destination alpha probably, and you'd early out in the destination alpha, but why you would want to waste all the bandwidth and the testing on a Z buffer when I just don't see what it gets you. So I'm not feeling it. I'm not feeling it. You're right, I did miss your question. I will Meblo, I will go back to that. Now that you said it, I can see it. But I must have missed it when I was scanning. Couldn't you set the sim bounds expansion from the screen dimensions or camera bounds in meters or something? Hope I'm understanding correctly. Yes, we could. I just don't know what to set it to. Because basically, like, the sim bounds are just what we want to... They're like acoustic bounds or simulation-related stuff bounds. I mean, basically what the sim bounds does is it simulates the stuff that's on screen and some amount of distance around the screen that we say is what we want high fidelity for. And so it's stuff that might make noise that we could hear, or it's people who might walk onto the screen or just walked off the screen and might walk back on. And we don't want them to go fall into some slow update loop. We want them to be like integral to the gameplay or something at that point, right? So I don't know, right? Like I really don't know what it should be set to. I don't know that it, you know, should it be an extra screen's worth? Should it be some fixed distance worth? I have no idea. And that's why I just put to do there, because until we have some more idea of like what should be happening, I really don't know what to set it to. But you could certainly set it based off the things you were suggesting. I just, even based off of those things, I don't know what it would be, right? So we'll see. Will you be implementing dynamic lighting or any deferred rendering for lots of real lights, etc.? So the problem with deferred lighting is that transparency doesn't really work very well. You got to do a lot of random stuff to make transparency work if you do deferred lighting. I'm sorry, deferred shading, really. So, you know, I mean, it probably not, because you get so much horsepower with modern GPUs for a 2D game. It might just be a waste of time to do deferred rendering, and you give up that translucency and a bunch of other things. So I don't know that it's a good trade-off. Deferred rendering tends to be more about managing depth complexity. And so I feel like we'll probably be able to manage depth complexity in other ways. Right? Because the only thing literally the only thing deferred rendering does is it cuts down on the number of computations that you have to do if you tend to overdraw parts of the screen a lot, right? That's it. That's all it does. It doesn't change anything other than that. And so if you have a lot of depth complexity where you're saying like, all right, you know, I'm looking at, you know, things through other things, like I've got kind of this this layered approach, where I don't know, like there's kind of a mountain in the way of a thing and a railing and this, that, and the other thing, and so I want to like kind of cut that down to just what's actually visible and not do computations for things that are stacked on top of each other. It makes, you know, a fair bit of sense. But how much of that stacking will we actually have versus the cost of doing the deferred rendering, right? And so I don't know. If it turns out that we're in a situation where we have tons and tons of overdraw, then, you know, maybe it makes sense. But if it turns out that we don't, then deferred rendering is just a waste of time. And it's worse because you don't have translucency and other things like that you might want. Or you have to do crazy stuff to get them. Is there anyone you can suggest for a hardcore render guy? Well, they're few and far between these days. But you know, you'd want to ask like someone on maybe like an NVIDIA, one of those guys who does the NVIDIA like sort of research, an NVIDIA research guy, or maybe someone on one of the engine teams, like you know, like a Frostbite rendering guy, or one of the guys from the Unreal Engine rendering guys. I mean, like I said, they're few and far between these days, so I don't know. But yeah, I suspect they're going to tell you that a 2D game usually doesn't need a Z buffer, but you know, could be wrong. All right, I think I'm going to go ahead and wrap things up. I think we're at the end of the questions about what we were doing programming-wise. I'm pretty happy with how that came out. I am pretty happy with that. So I think basically all we need to do tomorrow is turn these into seamless, and then we will have our sort of infinite ground texture that we wanted, which is pretty great. Oh, we got, and we need an eviction scheme. So we got two more things to do. And so that's what we'll do tomorrow. First, we'll get rid of the seams, because that seems to be that's the most ugly part of it, right? First, we'll get rid of those seams, and then we can go ahead and, yeah. Then we can go ahead and do the other part. So that's pretty cool. I'm happy with that. All right. Anyway, I'll go ahead and shut things down here. Save our mischief. Okay. Thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along with the source code at home, you can always pre-order the game on handmadehero.org. Basically, you can pre-order it, and it comes with a link to the source code, so you can download it every night after I finish programming and play around with the stuff we did on the stream that day. We also have a Patreon if you want to support our video series. That's just a purely optional subscription thing if you're interested in it. It's always much appreciated. You can check that out. We also have a tweet bot that tweets the schedule. So if you're trying to catch the stream and want to know when it's going to be, that's the place to go. And finally, we have a news and forum site, and the news and forum site has a bunch of great stuff on it. It's a place to ask questions. It has ports to Linux and Mac if you want to follow along on other platforms, that kind of thing. And it's got an annotated episode guide done by members of the community, which is pretty great for following along, catching up with old episodes. So definitely check that out if you're interested. Otherwise, I will see you back here tomorrow when we will finish up our Infinite Ground texture. Same time, same place, 5 p.m. Pacific Daylight Time, right here on Twitch. So thanks for joining us, and I will see you tomorrow.